So what is operational amplifier? So this is basically amplifiers which amplifies small signals. Okay, why we call it operational amplifier? Because it is used to, okay, or it is capable of performing some mathematical operation. Okay, so it can perform, or it performs mathematical operations like, okay, addition, okay, subtraction, differentiation, okay, integration, etc. Okay, so because with this device you can operate, okay, or perform mathematical operation, that's why this is generally given the name as operational amplifier. Okay, this is a linear device. It is a linear device. Okay, now if I see the symbol of this operational amplifier, okay, it's a shape like a triangle. Okay. So it can have many terminals, but three terminal, basically it is called three terminal device. Okay, it can have many terminals because three terminals are very important. Two are input terminals, okay, two are input terminals, and one is output terminals. So out of these two input terminals, they are high impedance terminals. Okay, so it has two high impedance terminals. Okay, so one is called this, where this is a plus sign, that is called non-inverting terminal. It is called non-inverting terminal. Okay, and where this is the minus sign, okay, minus sign, this is called your inverting terminal. Okay, now what is the meaning of non-inverting and inverting terminal? It will be clear in a short moment. Okay, so along with these three terminals, it can have many more terminals, as I told you. Okay, the two terminals which are, again, you can call it, they are also important. They are biasing. Okay, so we have to give some biasing to perform any amplification. So these terminal, okay, we are able to give here VCC and minus VCC to the operational amplifier. So these are the biasing terminals. So these five terminal are sufficient, okay, for us to understand the operation of a amplifier. आपकी जो एग्जाम में जितने भी प्रॉब्लम्स आती हैं वो बेसिकली इन टर्मिनल्स पर डिपेंड होती हैं. इफ यू अंडरस्टैंड दिस वर्किंग ऑफ दिस टर्मिनल्स, you can easily solve any problem of operational amplifier. Okay, now let me explain you what is your inverting terminal, okay, and non-inverting terminal. So non-inverting terminal का मतलब है कि जब भी आप इस पे कोई सिग्नल दोगे, ओके, तो जो आपको जो आउटपुट होगा वो इन्वर्टेड होगा. फॉर एग्जांपल, if you have this terminal, okay, and you give some signal here, b signal here, b input here, okay, making this as a ground, then what will happen at output? The output will be, because this is a non-inverting terminal, so output will be also in same phase. Okay, so output is in same phase. Okay, output is in same phase. Output is in same phase as input. Okay, That's why this is called inverting terminal, non-inverting terminal. Okay. Similarly, if you apply signal, okay, say this is your minus, this is plus, but this time suppose you are grounding this one and you are giving signal here. Okay, any signal when you are applying non-inverting, inverting signal, inverting terminal. Okay, then your output V naught, okay, will be in inverted phase. Okay, so this is called inverted output. Inverted output, that is output is at 180 phase. Okay, output is at 180 phase difference. Okay, output has, okay, one output is at 180 phase difference of input. So whenever any signal you apply, okay, that gets changed. If you're applying positive, this becomes negative here. If you're negative, that becomes positive here. Anything you apply at inverting. Okay, so this is your inverting terminal. Okay, and this is your non-inverting. Now I told you this is your amplifier. Okay, so what do you mean by the amplifier? So any signal you give, it gets simply amplified. Okay, now this point is clear. Okay.
Yes, sir.
Okay. Just give me, it's not visible properly. Okay. Now operational amplifier, okay, it is used in two configuration. Okay, two configuration. One is yes, open loop configuration, and second one is your closed loop configuration. Okay, now what is open loop configuration? Open loop configuration, so say you have terminal plus minus, यहाँ पे तो terminal है, and you are giving some input here. So you are giving B plus here and B minus here. Okay, and the difference of these V plus and V minus is given by V plus minus V minus. Okay, so what will be the output? The output will be, okay, so you're basically your operational amplifier amplifies the difference of voltages at the its two input. Okay, that's why it is called difference amplifier also, differential amplifier also. So you have V plus V minus, so your V output will be simply A, okay, V plus minus V minus, and you can call it A VD. Okay, so basically this is the equation for open loop gain. Okay, so your V output will be equal to open loop gain. Okay, so A is open loop gain, and VD is the difference of voltages at two input terminals. Okay, now this is open loop configuration. This is open loop configuration. Okay. So you can, if you want to, you can also write this V naught as a this is the open loop gain, and this is your VD. So you can also mention this way. So anything you apply here, the difference of these two will get amplified, and AOL is what? AOL is your open loop gain of amplifier. Now this open loop gain amplifier is generally very high. Okay, generally very high means, okay, if for ideal operation amplifier we take this A as infinite. Okay, so generally it is on an order of 10 to the power 5, 10 to the power 6, or ideally we can say this A open loop gain is infinite. Okay, now let me draw the equivalent circuit of a. Now what is this is open loop configuration. Now what is what is closed loop configuration? Closed loop configuration का मतलब है कि if some feedback is coming from output, okay, either at inverting terminal or out or non-inverting terminal, then that will be closed loop. Now this is open loop because there is no feedback from the output. Okay, so open loop configuration का मतलब क्या है? No feedback from output terminal, okay. Closed loop configuration is what? Okay, with, okay, so there exists okay, feedback path from output to one of input. Okay, this is open loop configuration. And now suppose if I draw like this is plus minus, and this is my V naught, and some way if here some feedback is coming, okay, to this positive terminal, okay, then it is called positive feedback. This is closed loop amplifier, okay, with positive feedback. And similarly, if output is coming, the feedback is coming to non-inverting terminal, okay, then it is called negative feedback. Okay, so this is positive feedback. Positive feedback means output, the feedback is coming to plus terminal. Similarly, if feedback is coming, so this is minus, this is plus. Okay, suppose this is coming, feedback is coming to negative terminal. Okay, so this is RF and say this is R1, and you're applying some B input here, then this is called your negative feedback. It's called your negative feedback. Okay, so both are this configuration. Okay, they are closed loop configuration. Okay, closed loop, I'm again repeating, open loop means there is no feedback from the output to input. Closed loop means there is a feedback from input to output. So whenever there is a feedback either at plus terminal or minus terminal, this will change this is the potential, this will change this potential. Okay, if this loop is not there, whatever voltage you apply, that will come to here. Okay, but if there is a loop, if there is feedback, then this voltage, okay, depending on the type of feedback, whether it's negative feedback or positive feedback, this property will change. This voltage at this terminal will change. Accordingly, your gain will also get change. Okay, now इसको erase कर दूं इसको मैं?
Yes, sir.
Okay, now you have to understand that even though I'm telling that operational amplifier has a very high gain, infinite gain, okay, but that does not mean that you can amplify any signal, okay, or whatever limit you want. You cannot infinitely amplify any signal. Okay, so there's a property of saturation. Okay, so that is called saturation property. Okay. Saturation property of operational amplifier. Okay, saturation property of amplifier says that output of any operational amplifier Okay, V naught is always between the limit minus VCC to plus VCC. Okay, what is minus VCC to plus VCC? Just now I was told you that you have this plus minus, you're applying B plus here, you're applying B minus here, and you are getting V naught here, and your V naught is nothing. V naught is a difference. Okay, you have open loop gain, and this difference get amplified. Okay, and this is this, you have this is your power supplies. This okay, biasing voltage plus VCC or minus VCC. Okay, so so even though this is a infinite, but this difference, okay, this output cannot be greater than this one. Okay, output of the operational amplifier is always always less than the applied biasing. Okay, so suppose I give you some value of operation, this AOL, and I'm giving you some voltage, okay, positive and minus. So if the difference is positive, and when the difference is greater than VCC, okay, what is the meaning of the saturation property? If VD, okay, VD is your V plus minus V minus. If VD is greater than VCC, okay, if it's positive and greater than VCC, then your V output will get saturated. Then V output will be equal to V saturation, and that will be saturated to V plus VCC. Similarly, if my difference V plus minus V minus is negative, okay, that means here is the higher potential, and I'm applying difference of voltage. Okay, in that case, if VD is less than minus VCC, okay, then again your V naught will get saturated. V naught will get saturated, and it will saturate to minus VCC. Okay, so what I'm trying to say, you apply here some signal, that signal get amplified here. Okay, but but whenever the gain is such that the difference is greater, this output becomes greater than that one, then the output will get saturated. Okay, output will not go beyond your VCC biasing value, otherwise there will be this violation of energy conservation. No? You cannot apply amplify something from out of nothing. Okay, so here you're applying this batteries. Okay, there's these batteries only help you to amplify this signal. So then output cannot be greater than these two batteries. Okay, so now this is called saturation property. Now let me make the graph, okay, to understand this curve. Now shall I erase this one?
Not left side.
So if you have a ideal op-amp, okay, if you have ideal op-amp and you are applying some voltage difference, okay, if voltage difference is positive, then output will be always plus VCC. Okay, thoda sa bhi, if you apply little bit positive, because the gain is infinite, automatically this will become greater than VCC in open loop configuration. So output will always saturate to VCC. This is for ideal case. Similarly, if you're applying negative voltage difference VDD, that means this is higher than this one. Okay, and this difference will get multiplied with gain. Okay, so that will saturate to minus VCC. Okay, so whenever there is a positive difference, voltage difference at input terminals, your output will be VCC, and whenever there is a negative difference of voltage, your output will be minus VCC. This is for ideal op-amp. Okay, but if this is true, then you will not able to amplify any signal. Okay, only the amplification will be up to this biasing voltage. Okay, but this is the ideal op-amp. In practical cases, okay, in practical cases, for some range you can amplify, linearly amplify. Okay, so this is your VD. So for some range you can when the difference is very low, at these terminals, you can amplify a little bit and then it will get saturate. Okay, 2 plus VCC. This is your output V naught. It will get saturated 2 plus VCC. Similarly, this happens for negative side also. For some some difference, it get amplifies linearly and then it gets saturated to minus VCC. So this is your practical op amp. This is your practical operational amplifier. Okay.
सर इट मींस मतलब हमें जितनी एम्प्लीफिकेशन चाहिए होगी वी हैव टू यूज द वीसीसी मतलब उसी अकॉर्डिंग
हाँ, बाइसिंग पे डिपेंड करेगा, बाइसिंग से ज्यादा नहीं हो सकता, ठीक है। और थोड़ा सा भी ये जैसे ओपन लूप कॉन्फ़िगरेशन, ओके, दीस इनपुट सेंस द डिफरेंस, ओके, थोड़ा सा भी डिफरेंस लगाया तो वो क्या हो जाएगा, आइदर प्लस वीसीसी पे जाएगा या माइनस वीसीसी पे जाएगा, ओके। और प्रैक्टिकल में थोड़ी देर आपको लीनियरली एम्प्लीफिकेशन मिलेगा, पर थोड़ा सा ज्यादा होता ही, बिकॉज दिस हैज टू मल्टीप्लाई विद द गेन, ओके, गेन इज हाई, so any difference you apply, okay, that will for some time it will get like suppose 0.000 difference is there, that suppose you have gain 10 raised to power 5 a, and you are multiplying this 0.0000 difference is there, then that will be linearly amplified. But suddenly when this difference increases, then the output becomes greater than VCC, then it has to be saturate, then it will get saturate, okay. Same thing happens in for negative side.
Sir, you said that gain of this operational amplifier is infinite for in the ideal op amp.
Yes. So ideal, ideal infinite का ideal है. So anything, any difference will apply, that will become infinite. Okay. So the output will become infinite, but output infinite cannot become infinite. Okay. It can max happen to this VCC. Are you getting? So when I say infinite, that means it's very high, 10 to the power 10 to the power 6. Okay. So your difference will get multiplied by this factor. Okay. Now if signal difference is very small, okay, if suppose signal difference is 1, then gain become 10 to the power 5. That, okay, that cannot happen, so that will be only saturate. Okay, so if difference is very small, difference 0.00, difference of voltages, okay, VD, if it is order of 10 to the power -4, 10 to the power 5, it will sometimes for some period it will get amplify. Okay, as it gets increasing, then it goes, output goes beyond VCC, then it has to saturate. The meaning of this one, in fact, the meaning is very high hai. That's it. Okay. So let me solve one problem to understand you what is your this saturation property. Okay, before I explain the internal structure of op amp. So no need to worry about this symbol. Okay, this operational amplifier also very easy. It's a linear device. Only you have to focus on 3 terminals. If you can focus these 3 terminals, okay, you can solve any problem, you can solve any problems of exam. Okay, so now suppose I'm giving you a problem which also came in exam based on the saturation property. You have been given this plus minus terminal and you have been given some V input. You are applying some V input here. Okay, and inverting terminal is here ground, and that is being given 5 volt fixed voltage here. This is 4 kilo ohm. This is your 1 kilo ohm, and biasing is given plus 10 volt and minus 10 volt. Okay, and to set it is the ideal. This is the ideal. Okay, this is the ideal op amp. Ideal op amp. Okay. So this is the open loop configuration. This is the open loop configuration. Open loop configuration. Okay. So, and they are given input. They say input is varying like this with time. V input is varying like this up to 5 volt. Okay, not up to 5 volt. It basically varying, okay, with time. Yes. So now this is your V input is given, this V input, and they are asking you to plot the V output of operational amplifier. Okay, so this is 5 volt. Now I know what is the output. Output is nothing. Output is just open loop gain V plus minus V minus. Okay. Now V plus, this is your V plus and this is your V minus. So I know from this given thing V plus is what? V plus is just nothing. This is a V input. Okay. And V minus is what? What is the value of V minus? Please tell me. What is the value of V minus?
1 volt.
1 volt. Very good. Okay.
1 volt.
So V minus is nothing. Voltage division. Okay. So you have this total 5 kilo ohm. So current will be 5 divided by 5. Okay. Into what is the voltage here? That is 1 kilo ohm. Okay. So if you divide this one, so this you will what? 1 volt. Okay. So V minus is 1 volt. Now your V minus is 1 volt is fixed, but V output, V input is changing. Okay. So I can say this is my 1 volt. This is my 1 volt. Okay. And this 1 volt, let us say this is my 5 volt. This is my 5 volt. Okay. Now this V input is 1 volt here up to here. Okay. So my scale will be up to here. So this is here 1 volt. Okay. So when V input is less than 1 volt, then what will happen? V input is, now this is a positive terminal and this negative terminal. When V input is less than 1 volt, in that case, okay, when my V input is less than 1 volt, okay, in that case my V output will be what? A open loop gain, B less than this is less than, so this will be negative, my gain will be negative, isn't it? My gain is what? My V output is what? My V output is A open loop gain, V plus minus V minus. Okay. If V input is less than 1 volt, that means this V plus minus V minus is less than 0, negative. So whenever there is negative, in that case, what happens? If the difference minus 10, very good. Whenever this difference is negative, I told you if it is 0, then 0. If you apply, if ideal, if anything difference you apply, that will saturate either -2 or +2. Okay, the output will be only minus or plus, minus VCC or plus VCC. So now this is less, this is more, this is 1 volt fixed, and this is less than 1 volt up to here. So that means the difference is negative, and the negative get amplified, that become infinite, minus infinite. That means your output should be now minus VCC. So for this range, your output will be minus 10 volt. Okay. Once it is go beyond, okay, once it go beyond greater than 1 volt, after that you are up to 5 volt. 5 volt it will be after now what is input is going for up to 0 to 5. Okay. So now anything you apply greater than 1, okay, it will give you only VCC plus 10 VCC. Okay, they asked up to here, so you can plot here.
सर सर वो V लेस देन 1 वोल्ट होगा तो क्या होगा, वो एक और बार रिपीट करें.
भी यहाँ पे ये this voltage is fixed now. This voltage is 1 volt. Okay. Now you're applying voltage here. This plus voltage. This voltage is 0. Okay, 0. Say 0.1, 0.2, 0.3, 0.5 up to 1. So up to 1, this voltage is higher. Okay, that means the voltage at in non-inverting terminal is higher, then this difference is negative. So whenever difference is negative, it will saturate, output will saturate to negative voltage, negative biasing VCC. Okay, whenever difference, okay, this is difference. Okay, whenever difference, this is time t. Okay, And now whenever difference of this V plus V minus is negative, it will saturate to minus VCC, and positive it will saturate to plus VCC. Clear है कि नहीं है कंचन?
Yes, sir.
तो क्योंकि नेगेटिव है ना, यहाँ पे कम है, यहाँ ज्यादा है, फिर एक के बाद में यहाँ ज्यादा हो जाएगा तो ये पॉजिटिव हो जाएगा. तो whenever you apply anything positive value at inputs, it gets saturated to plus VCC. So this is called your saturation property of operational amplifier. Now open loop configuration has a very less applications. Okay, so we have to mainly focus on closed loop, because in closed loop configuration only you can perform many operations like subtraction, differentiation, integration. Okay, and most of the property will be in your closed loop configuration. Okay, so before I discuss this closed loop configuration, let me discuss the internal structure of a op amp. Okay, so this is my op amp. This plus, this is minus. Okay, and here I am applying what? Here I am applying V plus, here I am applying V minus, and I am here I'm saying that is you have V naught. Okay, so basically here you have a input resistance called Ri. Okay, this input resistance is Ri, and at output you have a voltage dependent source. Okay, which is called A, or let me draw it a little bit bigger, okay, so that you can understand. So you have a diamond shaped symbol. Diamond shaped symbol is basically used for voltage dependent sources. Okay, and they say this is grounded, and here you have a resistance, output resistance called R naught, and here you are getting V naught. Okay, so this is your internal structure of op amp, or you can call equivalent circuit of op amp. Okay, equivalent circuit of op amp. Okay, so this is plus, this is a minus, and this is equal to AOL VD. AOL VD. Okay, now for ideal op amp, okay, we take Ri is infinite. Okay, open loop gain is infinite, and Ri also infinite. Input resistance is okay. So Ri is what? Ri is nothing. It is called input resistance. Okay, so basically it is equal to R Thevenin seen at input terminals. Okay, similarly your R naught. Okay, R naught is output resistance. Now output resistance is also R Thevenin seen at output terminals. Okay, and for ideal op amp, your R output is 0. This is open loop configuration. Okay, so as it is, this is open. So closed loop configuration भी तो बनेगा तो op amp से ही ना. Okay, जो open loop में तो ये matter तो करता ही है. That will also affect its closed loop properties. So now this is your this Ri is infinite here. Okay, Ri is infinite and R0 is 0. So once I put R0 equal to 0, so automatically what happens when I put R0 equals to 0, this implies what? This implies what? V naught equals to what? A all VD. Okay, अगर ये zero है, if this is zero, short circuited. Zero means what? No resistance. Then this point, this voltage at this point is equal to this point. Okay, and voltage is this point is equal to AOL VD. Okay, so depending on the difference, what difference is coming from here? What is the difference? VD, V plus minus V minus. You are getting output here. That is called voltage dependent source. Okay, so if this is zero, so whatever voltage come, that will be equals to your V naught. V naught equal to AOL VD. Okay. Now, for ideal op amp, okay, there are two important property which will be require, okay, or you can say which is sufficient to solve any problem. That two property you need to understand. So three property. One property you understand already, saturation property, that is useful when you are using open loop configuration. Okay, now whenever you're using op amp in a closed loop configuration, there are two property you have to keep in mind. Okay, number one property is virtual ground concept. Okay, and how much current is flowing in these terminals. That these two property you to understand.
सर सर आपने यहाँ R इनपुट में 0 लिख दिया है.
R input is infinite. R output is 0. R input is infinite.
Okay sir.
R input is infinite. Now, when I say this R is infinite or this gain is infinite, what are the consequences? Okay. So abhi jo kara raha hu, now what I'm telling you that is very important. Okay. If you remember these two property, you can solve any problem. Okay. Oh, op amp. So please listen carefully. When I say the number one property is called virtual ground concept. Okay, what is virtual ground concept? For ideal, so I take if op amp is ideal, if op amp is ideal, then I say my open loop gain is infinite. And I know what is open loop gain. Open loop gain is my open loop gain is infinite. That means my V output is what? My V output is AOL into V plus minus V minus. Okay, so if I say V plus minus V minus equals to V output upon AOL, okay, this is finite. Output is always finite. Okay, it cannot be greater than BCC. In that condition, my difference of this input signal will be V naught upon AOL. Okay, now I say this is infinite, so this become almost zero. Okay, so when this becomes zero, then what will happen? The voltage at positive terminal and at minus terminal will be always same. Okay, if I ground this one, then this will be automatically ground. If here voltage is 5 volts, here voltage will be 5 volt. If it's 3 volt, it will be almost 3 volt here. Okay, that is called your virtual ground concept. Okay, that is voltage at plus terminal, okay, equals voltage at minus terminal. In ideal case, only in ideal case, if op amp is ideal, then there will be no voltage difference between these two terminals, or you can say negligible voltage difference will be very small if your op amp is ideal. So this is the one property. This is called virtual ground concept. Now the second property is called your, if I say Ri is infinite. Okay, the second property is inverting and non-inverting, both inverting terminals draw no current. Okay, so these terminal will not draw any current because ये तो infinite है. Whenever this is infinite, infinite is means what? Open. Infinite का मतलब क्या है? Open. Whenever this is infinite, this is equal to open channel. R because open terminal का resistance is infinite, so that means there is no current is flowing. That means the I plus and I minus will be 0. Okay, so so that means if Ri is infinite, that implies your I plus equals to I minus both equal to 0. That means your input terminals draw no current. Okay, any current will not go through this input. Okay, because this is open circuit, all the current will go from outside. Internally there is no current okay from input here. If it was output for it to go from here. So that is a basically main equivalent circuit of, okay, basically your op-amp is made of many transistors. Okay, so transistors there, so but okay, equivalent circuit you can show by this. Okay, what is internal you don't bother, you only remember this one. This is your op-amp. Here input impedance, here is the output impedance, and this is your voltage difference. So any difference you apply, you get amplification AV or VD. If it is ideal, this will become 0. So your V naught will be equal to AOL plus V minus. Okay, and no current will flow from outside to inside. Okay, that means I plus and I minus 0. So these are the two property you have to remember while solving any problem.
Sir, how op-amp is a linear device?
भी कुछ भी वोल्टेज दे रहे हो तो लीनियरली तो वेरी कर रहा है उससे, आउटपुट जो आ रहा है डिफरेंस का वो गेन पे डिपेंड कर. ओके
सर, बट सर इंटरनल जो
उसका इफेक्ट बहुत कम होता है, बहुत कम होता है इफेक्ट उसका. ठीक है, now we can perform non-linear properties also with this transistor, but that for that we have to add separate accessories, okay, along with this op-amp. Okay, in general it itself is a linear device, because you can apply here your nodal analysis, because अंदर से तुमको मतलब ही नहीं है. Okay, internal structure we are not bothered. This is my equivalent circuit, and here now I can apply anything nodal analysis, whatever techniques I can apply on op-amp. Okay, like linear device.
Okay.
So let me now go back to the closed loop configurations. Okay. So first let me discuss non-inverting amplifier. Non-inverting amplifier.
क्लोज्ड लूप में नॉन इन्वर्टिंग.
तो नॉन इन्वर्टिंग एम्पलीफायर नाम ही क्लोज लूप में ही होता है. ओके, वो तो when it is open loop, then it is just a comparator. It will only compare the signals. Okay, so but let me explain what is non-inverting amplifier. So non-inverting amplifier, also called your voltage series feedback amplifier. Okay, is a name also. It's also called voltage series feedback amplifier. Common name जो है जिसको सब जानते हैं, that is called non-inverting amplifier. So non-inverting amplifier का मतलब क्या है? That you have plus minus, you're applying some signal to non-inverting terminal. Okay, and this terminal. Okay, so and there is a negative. This is the V naught, and some output is coming, some feedback is coming from the inverting terminal. Okay, so say this is my ground. Okay, so this is my RF and say this is my R1. So some feedback is coming to negative terminal, inverting terminal. Okay, so that is also negative feedback. Okay, so this feedback is negative feedback. Okay, so same circuit can be drawn like this also. So this, so you can also draw this way. This circuit also you can draw like this, plus minus. You're giving, whenever you giving input to plus non-inverting, that is non-inverting amplifier. Okay, same signal, same you can draw like this. RF, RF. The both circuits are same. Okay, and the usual way of drawing this circuit. Okay, what is the usual way of drawing this circuit? Generally, you can draw the same circuit. Okay, conventional way. Okay, so conventional way, what will be like this? This circuit is there. So here minus, your plus. So you will be applying V input to positive, and here this RF is coming from here. So this is your V naught. You have RF here, and this is your R1 here, and this R1 is grounded. Okay, so inverting is grounded. So these three, all the threes are same thing. Okay, same thing. You have V naught. Okay, and one feedback resistance there coming to the input, and there is a resistance. Okay, so these three type of things, they are same. Don't get confused. When sometimes they will draw like this, sometimes draw like this, sometimes they draw like this. Okay, so this is basically conventional way of drawing. This is a conventional way of drawing. Okay, conventional way of drawing. So non-inverting amplifier means what? You give signal to a non-inverting input while your inverting terminal is grounded. This is your non-inverting configuration. Okay. Now let us calculate. So this is a closed loop. Okay, amplifier, this inverting amplifier, non-inverting, both are closed loop and closed loop. So whenever you give something feedback from output to input, obviously now what will happen? Your gain will change. So now I will calculate my gain. Okay, closed loop gain I will calculate in two situation, when my op-amp is ideal and when my op-amp is not ideal. In both the situation, I will calculate the closed loop gain for non-inverting and as well as for inverting amplifier. Okay. So let me now put the heading gain. Okay, gain. Okay, closed loop gain. Closed loop gain is basically write ACL, closed loop gain. Okay, closed loop gain. Okay, that is written by AF or ACL, a closed loop gain. Okay, so I'm calculating for non-inverting amplifier. So this is my non-inverting amplifier. Non-inverting amplifier minus, this is your resistance here. You have a feedback resistance here. Okay, you have V output here. You have RF feedback vector is R1, and this is here, and this is my plus, and I'm giving signal here. V input I'm giving here. Okay. And this is your grounded, this terminal is grounded. Okay, so when this terminal is grounded, now I will calculate gain when the for ideal case. Okay, ideal case. So now suppose this is the ideal case, then for ideal case, for ideal op-amp, okay, my V plus should be equals to V minus. So if I'm giving V input to this terminal, automatically, okay, automatically here V minus, this will also become V input, isn't it? Are you getting this point? If my op-amp is ideal, So op-amp has two properties. Okay, one property is that the voltage of both terminals will be same. And at the terminal, no current will flow here. I plus, I minus will be 0. I plus will be 0. So no current will flow here. So whatever current is going, that will go from here to here. Okay. Now this is my R1. So this op-amp is ideal. So V plus will be equal to minus equal to V plus. So I can say my V minus is also equal to V input. This is V input. Now I can write here nodal analysis at this point. Suppose a current is coming from here and current is going here. Okay. So say this is I input current. Say this is IF. Now because this current is coming here, no current can go. That means all the current will go here. Okay. So if I write the nodal analysis also, so at say at minus terminal. Okay. I can write I input equals to IF, isn't it? Because the current is coming from here to here, that current is only going here. No current is going here. So now I can write I input is what? If I'm putting sign like this, you can put a sign opposite also. It is your choice. I am putting sign like this. Okay. Because sign doesn't matter for nodal analysis. No? So now 0, this is 0 minus V input. 0 minus V input upon R1 is I input. Similarly, V input minus V naught. V input minus V naught upon RF is my IF. Okay. Now you solve this one. What is coming? If you solve this one, you have minus V input R1. Okay. And you have minus V input upon RF. And then you have minus V naught RF, isn't it? Okay. So now if you take common minus V input, so minus V input will be what? That will be your RF plus R1 plus RF upon R1 RF minus V naught upon RF. Okay. RF cancel. So you are getting now okay. So now what is minus also cancel? Okay. Minus will cancel or not? So this V input minus V naught. Okay. I should put the minus here, minus common. Okay. And then you mean minus V naught upon RF. Now I want V naught upon V input. Okay. So V naught upon V input will be what? Okay. So V naught upon V input will be your
R1 plus RF by R1.
R1. Okay. So this will be your, and this is called your closed loop gain, ACL. Okay. So for non-inverting amplifier, your closed loop gain A is 1 plus RF upon R1, 1 plus RF. And this is a non-inverting, so sign has not changed. Okay. So your closed loop gain ACL for non-inverting ideal case, okay, is nothing 1 plus RF upon R1. Okay. So V naught will be simply 1 plus RF upon R1 into V input. So that get amplified by this factor. And this is for ideal case. Ideal case means a virtual ground concept is valid. Virtual ground concept is valid means the terminal of these terminal will be same. Now you have to also remember one thing, that virtual ground concept is only valid when your output is not saturating. When output gets saturates, then virtual ground concept is invalid. Okay, we'll see when we'll do some problems. So this is the ideal case, your gain. Now suppose if it is not ideal, okay, if it's not ideal, then what will happen? So if it is not ideal, then these terminal will not be same. The voltage of this terminal will not be same. Okay, for that case now we have to solve and we have to calculate this closed loop gain. Okay. इसको मिटा दूं मैं? Can I erase this one? Is there any question? Okay, ठीक है. So ये तो आ गया आपका आइडियल केस के लिए. Okay. Now put the heading. Okay. Exact calculation. Put the heading. Exact calculation. Exact calculation means now when it is not ideal. Okay. So if op-amp is not ideal, okay, that means open loop gain. Now open loop gain is finite. Oh, open loop gain is finite. Okay. Exact means now open gain is finite. When I say ideal, ideal means your open loop gain is infinite. That's why virtual ground concept comes. Okay. Virtual ground concept. Now the other property that terminals in inverting terminals and non-inverting terminals do not draw any current, that is always valid. Okay, whether it is ideal or not ideal, whether the gain is infinite or gain is infinite or some finite gain is there. These terminal will never grow a current. Okay, that will be, they will grow and draw any negligible current because the input resistance is very high, always very high for invert this operation amplifier. So this property will be always valid. It will not draw any current. Only virtual ground concept only becomes valid when there is a AOL is infinite. Okay. Now I'm taking exact case. That means your AOL finite. So this voltage will not be V input. Let it say this is V minus only. Okay. Now for this case, we have to solve again the circuit. Okay. So now in this case, what will become? This is my current. Okay. So now my current will be what? Minus 0 minus V minus upon, this is here is V input is coming. Okay. 0 minus V minus upon R1. That will be equals to what? Minus V minus V naught upon RF in this case. Okay. Now I also know that my closed open loop gain OL, okay, or my V output is nothing. My V output is a open loop gain into V plus minus V minus. This is my open loop gain. Okay. So in previous case, this V minus was equal to V infinite. Okay. Now in this case, particular case, I'm taking V not equal to AOL, V plus minus V minus. Okay. And AOL, V plus, I know this is the V input, and V minus is V minus. Okay. Now calculate the V minus from here and put this here. Then you get the.
इस केस में आइडियल op-amp नहीं होगा फिर.
इस केस में आइडियल op-amp नहीं है. Now find out what is the value of V minus here. Okay, what is the value of V minus? So V minus क्या हो जाएगा आपका? So this equation implies, okay, V minus upon R1. Okay, and this also coming V minus upon RF equals to minus V naught upon RF. Okay, and again minus V minus is again R1 plus RF. Okay, and R1 RF. This is minus V naught RF. Minus minus cancel. Okay, RF cancel. Okay, now you have this V minus value is like this. So your V minus is nothing. V minus is so your V minus is basically, okay, that is R1 upon R1 plus RF, okay, into V naught. Okay. So basically at minus terminal, this is 0. This is not giving any contribution. So contribution in non-inverting amplifier is coming only from output. Okay. So here resistance are RF. So this V naught is coming. Some voltage get consumed here. The remaining comes here at R1. Okay. So this is the feedback. So I call this R1 upon R1 plus F also beta V naught. So your V minus whatever the voltage is here, okay, basically coming from V output as a feedback. Are you getting my point? This V naught get distributed between RF and R1. Okay, so how much voltage is at R1 due to this V naught? That will be R1 upon R1 plus RF into V naught. That is called beta V naught. If this point is clear or not? If not clear, let me please tell me again. I'll explain again. So this is basically V minus is the feedback at inverting terminal due to output. So I know now V minus. Okay, put the V minus value here and solve for closed loop gain. Okay, so let me solve now for closed loop gain. इसको मिटा दूं ना? Now my V output is A open loop gain. Okay, V input minus this one. V minus is R1 upon R1 plus RF V naught. You can also write beta V naught also. Okay, we'll later we will write beta V naught also. V naught. Okay. Now take this V naught there. So V naught plus AOL R1 plus R1 plus RF V naught equals to A naught L V input. Okay. So now V naught will be what? V naught will be 1 plus A naught L R1 plus R1 plus RF AOL V input. And from here, I can calculate the closed loop gain A CL V naught upon V input. Okay, what will come? That will come AOL upon 1 plus AOL R1 upon R1 plus RF. Okay, and this also can be written as R1 plus RF AOL, okay, upon R1 plus RF plus A naught all R1. Okay, so this is your basically formula for this closed loop gain, and this can be simplified further. Okay, generally if I want to write this in terms of beta, if I want to write this in terms of beta, so my beta is what? Beta is like this. So you what you do, you divide by this thing. So what will come? So you have closed loop gain A CL. Okay, so you can also write this as a AOL upon, if you divide by R1 plus RF, that become 1 plus R1 upon R1 plus RF AOL, and this you can write AOL 1 plus A beta, or sometimes you write as a B also. Okay, beta or B. Okay, whatever you want to write. Okay, so let me write beta. So A beta. Okay, so this is your closed loop gain in terms of open loop gain. Okay, and this is your A open loop gain, and this is your beta. So whenever there is a negative feedback, okay, your closed loop gain is always less than your open loop gain, and this given by this formula depending on how much is feedback here. So this is the formula. Okay, here while applying this formula, you should always remember the beta is your feedback, that is R1 plus RF. So basically your AOL is your open loop gain, this is a closed loop gain, beta is gain of feedback circuit, beta is the gain of feedback circuit, and A beta is called the gain of loop, feedback loop, gain of loop. Okay, or loop gain. Simply is called loop gain. This is called your loop gain. So this was your non-inverting amplifier, both inverting, both ideal and non-ideal cases. Okay. Now non-inverting amplifier का मतलब क्या है?
ए क्या है?
ए कौन सा ए?
A
ए ये ओपन लूप गेन. A
okay.
is open loop gain. Okay. A is your open loop gain. AOL you can write simply. Generally they write AL. Generally A closed loop is written by AF in many books. Okay. A after feedback. AF. A after feedback or A closed loop gain, and this open loop gain generally they mention by only letter A. Okay, now let us do again this for inverting amplifier. Same thing for inverting amplifier, and let us calculate the formulas again. Okay.
Sir. Sir, what is difference between this loop gain and closed loop gain? That's our gain of the closed loop ना दोनों ही.
भी open loop का मतलब क्या है? When there is no loop.
हाँ जी, तो loop नहीं होगा तो then there would not be any feedback also.
So there will no feedback. Then whatever gain is, that is called open loop gain. Okay. Now when you putting some
loop gain जो हमने किया loop gain.
Loop gain is A beta total. Name is given loop gain A beta. Okay. Now whenever you give some feedback, that gain will change. We have seen the equations. Okay. That is called your closed loop gain. And closed loop gain again in ideal case, and in practical case, we have seen both the cases. Okay. So whenever they say op-amp is ideal, you can use ideal formula. Okay. And if it says gain is, whenever they say gain is finite, then you have to use the exact formula. Be clear in mind. Okay. So generally questions they ask, they did not tell anything. So when they did not tell anything, that means your op-amp is ideal. But if particularly they say the open loop gain is finite, yeah, if they give the value of open loop gain, then you have to use the exact formula. Okay. Just now I was showing you the formula that A closed loop gain. Okay. This formula was what? A plus is open loop gain plus A beta. Just now I shown you, no? Okay. Now if I say if this is open loop gain, now if it's ideal, if open loop gain is ideal, then what will happen? This go infinite. Okay. So what I can write? I can write A, this equation I can write what? 1 plus 1 upon A naught L plus beta. And if A naught is infinite, this term will become 0. So your closed loop will be simply 1 by beta, and closed loop gain 1 by beta. Beta is what? Beta is nothing, your R1 plus RF. This equation become what? R1 plus
कॉमन क्यों
R1 limit लगाने के लिए भी 1 plus RF upon R1, and this is the ideal case. कॉमन क्या लिया? यहाँ से मैंने इसको डिवाइड कर दिया, AOL से डिवाइड कर दिया इधर. ओके.
हम डायरेक्ट AOL इनफाइनाइट रखते तो ACL इक्वल टू AOL.
क्या? अगर डायरेक्ट इनफाइनाइट को तो ये भी इनफाइनाइट हो जाएगा ना, इनफाइनाइट बाय इनफाइनाइट हो जाएगा ना. लिमिट कैसे सॉल्व करते हो?
सर AOL इनफाइनाइट थोड़ी ना लिया हमने, वो तो फाइनाइट ही लिया है ना.
AOL तो इनफाइनाइट लिया है. ये तो मैं आइडियल केस की बात कर रहा हूँ. ये तो हमारा फॉर्मूला है क्लोज के लिए. अगर मैं बोल रहा हूँ कि मेरा आइडियल है तो क्या हो जाएगा? ये इनफाइनाइट हो जाएगा. तो आइडियल केस में हमको वही फॉर्मूला मिलना चाहिए जो हमने निकाला था आइडियल के लिए पहले.
यस सर, यस.
ठीक है. इफ आइडियल, इफ AL that is ideal. Okay. Then the same formula we are getting what we derived for ideal. Are you getting these things? So this is the exact formula. This is for ideal formula. So this is for ideal case. So only you have to remember these two properties: virtual ground concept and terminal do not draw any current. Okay, that's it. पूरा ओपन में ये करना है. So now let us do for inverting amplifier. Okay. Inverting amplifier means what? Inverting amplifier means now you have loop is same, it is still negative. Now your input you are giving to R1, you are giving input to this one R1, and there is also feedback. We not here, and this plus terminal this time grounded. When in normal terminal, so this is your inverting amplifier. Inverting amplifier. This is a common name. Okay, it has a one more name that is called voltage shunt feedback amplifier. It's also called voltage shunt feedback amplifier.
So feedback is always given to the inverting terminal.
Yes, this is for negative feedback. Okay. So when you give to feedback to inverting, that will become positive feedback circuit. That will be also discussed in the end. Okay, that has only very limited applications. So main important is negative feedback is more important, because negative feedback will stabilize your gain in the circuit. Many property will improve. Okay, we'll discuss that one. Okay, what is the difference between positive feedback and negative feedback? Negative feedback has a lot of applications. So this is your RF. Now calculate the gain for ideal case and non-ideal case. Okay, so very simple. Calculate gain, closed loop gain, closed loop gain. Okay, first ideal case. So whenever it is ideal, the voltage will be same. If this voltage is 0, this will be automatically 0, isn't it? Are you getting this point? If this is grounded, this will be already 0. Simply apply. Say a current is flowing like this. Current is coming here. Say IF. Say the I input. Okay. Here they are not drawing current. So I plus I minus is 0. I plus is also 0. So this current is going here. If I apply nodal analysis, I can write V input minus 0. Very simple. Okay, this applying nodal analysis is very simple in op-amp. Okay, R1. Okay, then 0 minus V naught upon RF. Okay, so now my V input minus V input, that is a closed loop gain, become minus RF upon R1. Okay, if you want V naught, that will be simply minus RF upon R1 V input. Okay, so this is your closed loop gain. Okay, a closed loop gain is minus RF upon R1. Now this is, say, sign is changed. The voltage output sign is changed because this is an inverting amplifier. Okay, earlier we was 1 plus RF upon R1. Now this is minus here. This is ideal case. Again, here also feedback coming. Feedback is coming what? At R1. You are applying voltage, something is getting lost here. Okay, and remaining coming here. So again, feedback is beta V0. But earlier, this was grounded. So now I don't know what is the voltage here. Okay, because some feedback coming from here, and we are also applying V input also. In previous case, in non-inverting amplifier, this was grounded. So only feedback was coming to inverting was equal to, that was equal to beta V naught. Now it is different. Then okay, now this will come for due to this one and due to this one, superposition principle. What is coming from this one and what is coming for this one? Okay, so for due to this one, voltage come here, that will be contribution to this terminal. For this voltage, this will be loss, and this whatever voltage come here, that will be contribution to this one. So summation of these two contribution from output and input will come here. Okay, that can be done many ways. So let me do a simpler way. So this is ideal case. Now let me do for this for a exact calculations. Okay, exact means AOL is finite. Okay, so I know the V0 will be always for this amplifier, that will be A open loop wave V plus minus V minus. Now V0 AOL, V plus in this case is 0. Okay, minus V minus, and they say this is V minus now for ideal case. Okay, so my V0 will be simply minus AOL minus V minus. Okay, now let me apply equation in the loop. So now what will happen? My V input minus V minus upon R1 will be current. Okay, again applying current, I input is equal to IF. V minus upon V0 upon RF. Okay, so for gain I need equation only in terms of V0 and V input. So V minus value I can put from here. Okay, so you put the V minus value here, V input minus V minus. So V minus is nothing, V minus is what? Minus V0 upon AOL. So this minus become plus V0 upon AOL. You can simply add A also. Okay, A, and this is your R1, and then V minus is again minus V0 upon AOL. Okay, minus V0 upon RF. Now solve this equation and find the gain. Solve this equation and give me the expression for gain. Now you can solve this further. You have V input upon R1. Okay, and you can RF, you can also bring here. RF also you can bring here. So RF go here, and you have, so V input upon AOL R1, this will come here. So you have minus V0 upon AOL. Okay, RF minus V0 upon RF, and one minus this also coming here, minus V0 AOL upon R1. Okay, and if you solve this one, V input RF upon R1. Okay, take minus V0 common. So what you left? So you have RF also there, RF also there, RF also there. Okay, so if you take V0 common, okay, so what will get? You get AOL RF, okay, plus 1 upon RF, okay, plus 1 upon AOL R1. Okay, now you can get the loop. So V0 upon, okay, you can further solve this one. Okay, and I'm writing the direct expression. You tell me whether you're getting or not. So now if you take this one, okay, so the what I'm getting a closed loop or AF V naught upon V input is equal to minus A RF, okay, R1 plus RF plus A open loop gain R1. Okay, checked. This is coming or not coming?
Yes, sir.
By solving this one. Coming?
Yes, sir.
बाकी को भी देख लो, करने दो बाकी को भी. So you can take minus
Yes.
V naught. Okay, you can take one AOL common. So this become RF plus R1 upon RF plus R1. Okay, and one upon RF is already there. Now इसको नीचे भेज सकते हो. Okay, now if you solve this one, you can get this formula. Now if you want, you can write this formula in terms of beta also. This is AOL. Okay. So I'm erasing this one. Okay. So this is my formula. Okay. So now this is my closed loop gain. Okay. Minus AOL. I can write this equation as a RF upon R1 plus RF and dividing by this one. Okay. So this become what? This will become automatically 1 plus AOL, and this become R1 upon R1 plus RF. Okay. Now, just now I have drawn the circuit. I told you what is happening. This is minus, this is plus. This is R1. This is RF. RF is here. This is my V naught. Here was V input. Okay, and this was grounded. So I told you the contribution of V naught here. Okay, coming as a R1 upon R1 plus RF. Similarly, contribution of V input is coming here RF upon R1 plus R1 into V input. Okay, so now this, okay, if I write this as a V output upon V input, okay, a closed loop gain. So what I can write now, this contribution RF, this is contribution due to V input at V minus. Okay, so we are applying V input. Okay, so and so this will be what this I write as a K. Okay, I write this as a AOL. This I write as a K. K is the K, and this I write as a 1 plus AOL, same like beta. So formula is same now in terms of beta. So you get K. Okay, and K is what? K is called your a voltage attenuation factor. Okay, K is called
सर एक बार के दोबारा बता दो.
हाँ बता रहा हूँ. K is called your voltage attenuation factor. Okay, and this is your beta. Okay, beta क्या है? Beta is gain of the feedback circuit. Okay, gain of the feedback circuit. Okay, so this is your RF upon R1 plus R2, and this is your what? This is your R1 upon R1 plus RF. Okay. Now let me explain it again. So I'm erasing this one. Okay.
सर ये बता दो सर RF
हाँ हाँ
over
बता रहा हूँ ना, बता रहा हूँ. Just now I have drawn this one circuit ना. This minus plus. This was your V0. This was your RF. This was your R1. Here V input. Okay, and this is your plus. Okay. Now, if I want to calculate how much voltage V minus is coming, so V minus is basically sum of this voltage and this voltage. Okay, this will give you contribution here as a V sum, V feedback. This is the direct contribution, V input. Okay, so if I want to see what is the V minus, so V minus is basically what? Okay, so if I want to calculate the contribution of V input at V minus, so what I can do, I can make it ground like superposition principle. If I want to write V minus, so V minus is what? If I want to see the effect of one source, other I have to ground it. Okay, so if I want to see what is V minus coming due to this V input, so how much will come? So this voltage will loss here, and what is the voltage here? So what here voltage is basically due to V input. So V input will be V input
by R1 plus RF.
RF upon R1 plus RF. Okay. Similarly, if I want to see, if I want to make this ground, I want to see voltage this V0. Okay. Now total V will be sum of this voltage. What is the voltage here? Okay, that will be your simply R1 upon R1 plus RF into V0, isn't it? ये आ रहा है कि नहीं आ रहा है?
Yes sir.
Okay, so now ये जो फैक्टर है, ये तो इसको तो हम बोल रहे हैं फीडबैक गेन, क्योंकि आउटपुट से आ रहा है. ठीक है, आउटपुट से कंट्रीब्यूशन आ रहा है, और इसको बोल रहे हैं हम अटेन्यूएशन फैक्टर. ये जो RF है, यहाँ पर जो RF अपॉन R1 प्लस RF है, इसको हम बोल रहे हैं कि जो इनपुट से आ रहा है. बस एक मिनट और दे दो मुझे. यस, okay. So from here, what we are getting the relation, just now what I have written the relation, A open loop gain, closed loop gain is equal to K AOL upon 1 plus AOL beta. Okay, so this what I can write, this again I can write is a K into, okay, gain of non-inverting amplifier. This A upon 1 plus A beta was the gain of non-inverting amplifier. Okay, now I'm telling this is a attenuation factor. Okay, so this you can understand this way. Suppose your V0 is coming this one. Okay, so this V0 is getting lost here, remaining coming here. Okay, are you getting? RF, you are consuming voltage feedback at RF, okay, and remaining coming here. That is why it is called your attenuation factor K. Okay, and in other case, here you are, and other case this is a gain, because this voltage coming is as a gain here, and you're losing here. So this is attenuation, and this is coming as a gain. That's the meaning. That's the name is given. The only name. Okay, So I'm stopping here. Tomorrow we'll do problems of this inverting and non-inverting both. Okay. So any question, please ask. Okay. So I'm stopping here. Thank you very much.
Thank you, sir.